Hi guys, my name is Muhammad Ahmaduddin, and today I'll be telling you about mass transfer in distillation column. Mass transfer and where it happens in distillation column. In industrial processes, mass transfer operations include separation of chemical components in distillation columns, absorbers such as scrubbers or stripping, adsorbers such as activated carbon beds, and liquid-liquid extraction. For application in chemical engineering, the driving force for mass transfer is usually a difference in chemical potential. So, where mass transfer in distillation works? The mass transfer happen at the trace or around the packings where the vapor and liquid came in contact. So this is the equilibrium stage concept. We focus on the middle part for us to make the material balance. So the middle is stage I, the bottom is stage I minus 1, and top stage is I plus 1. L is liquid flow rate, V is vapor flow rate, X and Y is mole fraction for respective types. So the material balance stage is LIXI plus VIYI equal to LI plus 1, XI plus 1, plus Vi minus 1 plus Yi minus 1. But to calculate for the whole tree, using these 3x3 calculations is time consuming and often unnecessary. So one of the quick method of estimation for number of plates and feed stage can be obtained from graph of Mercator-Taylor method. So first, I'll be explaining about the graph explanation. From the Mercator-Taylor method, we will making a graph to predict the feed stage and the Q line. First, we construct the XY graph using VLE data. Usually the data used is from heptene ethyl benzene at 1 atm. Then we construct the 45-degree line, X equal to Y. After that, draw the feed line based on the quality Q line. Then, we plot the value of XB and XD on the axis. What is XB and XD? XB is the mole fraction at the bottom and the XD is the mole fraction at the top. Then, draw the rectifying and stripping line by connecting the intersection. You only need to calculate either one of them. Lastly, make the horizontal line starting from the XD point to the curve, then vertical line to the operating line, and repeat until staircase is formed until reach the XW point. We can decide the feed plate by looking at which staircase is the intersection of the stripping line and the rectifying line. Now, how to make the rectifying and the stripping section. So first, we look at the overall column of the stage. We can see that the overall mole balance is F equal to D plus B, and then we focus on the component FZF equal to XDD plus XBB. Like key means more volatile components. Now we're moving to the rectifying section. The overall balance is V equal to L plus D, and the light key balance is VYN plus 1 equal to LXN plus DXD. And to find the slope of the line, we use L over V like the equation. Then the line is drawn starting from the XD point because we're using the rectifying section. While for the stripping section, the overall balance is L bar equal to V bar plus D, and light key mole balance is L bar XM equal to V bar YM plus 1 plus BXB, and the slope is L bar over V bar. The line is drawn starting from the XB point because it is the stripping section. The slope for the rectifying section is actually the reflux ratio.
In the relation with previous slide, the location of the Q line can be determined from various feed conditions. For example, if Q is bigger than 1, liquid is below boiling point. If Q is equals to 1, liquid is at boiling point, while if the Q is in between 0 and 1, it is a mixture between liquid and vapor. And if Q is equal to 0, it is a saturated vapor. Lastly, if Q is smaller than 0, it is a superheated vapor. In order to tackle questions regarding distillation column, there are several steps we must follow. The first step is we must draw and label the process of schematic diagram of distillation. Second, carry out mass balance of distillation column. And third, plot VLE or equilibrium curve line and 45-degree line on a graph paper if it's not given. The next step is to determine equation to plot ROL and determine equation to plot Q line. And the fifth step is to draw the stripping operating line by connecting the vertical bottom product line XB meets the 45-degree line and the rectifying section operating line. Lastly, draw theoretical trace starting from point where the top product line meets the 45-degree horizontal line XD intersects with the VLE curve. This equation might be useful in your calculation. That's all from our group. Thank you.